let's just get started with ColorAnt and some of the new features that we've implemented in ColorAnt 10.
We have a couple new custom chart functions that we can go through real quick. The first being that we are now able to create spot color charts. So let's just take a peek at how that works. I'm going to go over to custom chart, change it to spot color library, determine that I want 4 spots in this custom chart. And I'm going to just identify them really quick. Red, blue, green, violet. And of course I can go into these colors or into these and change the name into plum and change the color values or go based on a color picker. Let's try and keep it somewhat logically consistent. So let's go with that. Close that out. So now our values have changed. I'm going to hit OK. And now we have these 4 colors. And when I start, because I set my number of patches per color, it will create a set of tone ramps for each of these colors. Now, I can, of course, then export this chart and measure it. We also have the ability to create custom charts specifically designed for G7. We can do that by clicking Custom Chart, making sure that our color space is set to CMYK, and we can go down to Linearization and G7 Patches. When I do that, we will create a chart that is specifically designed to capture the patches required to accurately or most effectively create a G7 linearization. A lot of neutral print colors in there for your linearization run prior to creating the profiling run. So that's always useful. We always, of course, have the option to merge that with another chart. So let's say I get an IT 7.4 going in there, and I want to merge these to create a better G7 chart, but also be able to capture all that profile data that's in the IT874. I can just go into here and link them. Channel name. Okay. And now I have an interesting hybrid of that, and I can go make it. And I can export that as a chart and print that off and begin my profiling process. So we have, in addition to creating a G7 chart, we have several useful tools to help along the G7 method within ColorAnt as well as CoPrA, which we will get to shortly. I take some measurement data though in ColorAnt, and I use the evaluate function. We now have a G7 gray balance evaluation tool built in, and we can see that bad G7 data, surprise, surprise, is bad. And this seems to be just within tolerance on weighted delta L. So obviously not what we're looking for. So we're going to go to tone value, and we're going to do a G7 gray balance MPDC correction. I could protect my highlights if I was worried about that in Flexo, and I could also obviously output these compensation curves. We're not going to do that right now. Let's start. And so now if I evaluate these and look at the TVI based on G7 evaluation, We can see that we have a pretty smooth set of curves, and if I want to take a peek at what it was before, a little bit more wavy. So this is the correction that I just did, but we also have a couple other tools to evaluate that. First being in the evaluate function. We can now see that our weighted delta L is much lower, as well as the max of the weighted delta L. Everything seems to be passing, and we are in accordance with the G7 standard. We can also create a report that shows that. And let's just add a couple other things to make sure we're not missing anything. We're going to compare it to, let's not compare it. Save that out. Now, if I bring that report over to this window, we can see our usual profile reporting information, but now we're able to check the tonality curve as well as the MPDC curves for CMY and K. We are able to make G7 corrections to our measurement data and embed that within the profile through CoPrA. So if we go into CoPrA and we go into a new printer profile, see I have some loaded measurement data there. Let's go up to the default settings and go to customize. In the general tab, I can include the new edition G7 correction to the data set. Go on to next. And this all looks okay. And I will then call this G7 bad corrected. I'm going to save that profile. Now, if I go and find in my profiles folder, I can see that I have that data set now, that profile, which I'm going to drop in. And we can see that if I go and look at the original measurement data, it's a bit all over the place. But if I look at the profiling data, which we just created there, I can open that up, look at the TVI, switch it over to the G7 view, and we can see that our neutral print density is looking very good. I can then check that in the evaluation tool and see that all my G7 measurements are passing within the spec. We can also create a device link profile with a G7 correction inside of it. So we're going to start with some bad G7 data, and our target profile will be ISO data. I'm going to use the default settings, but customize, jump over to the rendering tab, and select apply G7 properties. Now, if I jump to the rest of the windows, everything looks pretty good. We're going to do most things on the default. And I'm going to call this default G7 correction and this stuff to double check. I'm going to hit save. But before we check what that did, I'm going to go back into this, create another profile with the device link profile without that checkbox checked, so we can do a comparison at the end. So this one is going to be called default no G7 Save that out. Now I'm going to go over to ColorAnt, and I'm going to load up two IT8s. Let's see, duplicate that one. And now I'm going to do let's call it bad G7. So device link, I'm going to do the first one with no G7 applied. Convert it back into lab. And then I'm going to do the second one with our G7 correction. Save. And now if I go into this one and bring my window over, we can see that there's a slight difference between the two, which there should be. And if we jump over to the neutral print density curves, we can see that our G7 correction one looks very good. And if we review our no G7 one, see that we are clearly not conforming to G7 standards. We can also check our evaluation and see that G7 correction falling well within our G7 standards. And this one is not. So that is the device link with a G7 correction built inside of it. And for a final type of G7 profile, we can also create a G7 linearization profile. So we are going to go to our linearization tab, load a data set. Again, I'm going to use that bad G7 data, which we know is not passing. I'm going to make sure that I am on the G7 linearization. Jump over to customize. If I was in Flexo, I might want to protect my highlights potentially a little bit from modifying these curves. But we can see that our calculated curves look pretty good compared to our original curves. Aren't terrible, but certainly not passing. So let's create this linearization profile. I'm going to call it a non-redundant version of that. And create a PDF profile report with that as well. Save that out. And if we want to take a peek at what's in the profile report, we can see that all of our usual information, profile statistics, our individual curves, as well as what we started with the tonality curve, our original neutral print density curve, our black neutral print density curve up here. And then here are corrected tonality curves and neutral print density curves, which, as we can see, they are now passing. Look at the new channel settings function in CoPrA. To do that, we're going to start by creating a new printer profile. You can see we got some remission data, 7 color, typical orange, green, violet. Nothing fancy here. We're going to start with the default multicolor settings. Go to customize. And if you go to the color generation tab, you can see that where these used to be just channel blocks indicating which colors were available, we now have the definitions on them. P, and as you can see if we open it up, P stands for primary color, K for black, and O for other.
And this was always built-in functionality, but now we give you more freedom to be able to adjust this as seen fit. Like if perhaps you wanted to create a chocolate bar by not including the cyan, you can now create maybe just an MYK profile, or you could include violet or orange or any of those specific settings while maintaining the profile entirety. So if we look at here, we can see we have a definition, which if I turn this off auto, we can now change each of these colors to be specific things. And then there is also this combination channel or a combination column. That is probably a bit more primary to specific fields, perhaps inkjet profiles or ceramics or other industrial prints where you need to expand your black with a light gray to be able to utilize the full width of that color, or maybe a light red and a dark red, or, you know, a lot of options there. Generally speaking, it's probably best just to leave it on auto, so that way CoPrA is able to go in and identify which colors need to be combined to maximize your gamut and give you the biggest possible gamut. But so for starters, we're just going to leave it as a traditional orange, green, violet profile. Okay, here didn't change anything. It says edited. Go to next, and we're just going to call this test full ICC. I'm going to hit save. You can see that that is saving now. And then I'm going to jump over to ZePrA to show you this in action. And I'm going to go to this output config where I have my 7-color profile, test 1 full. I'm going to, I don't need to save it because it was already set on that. My original testing. I'm now going to go to overview, and I am going to reprocess a job throughout that, or through that output profile. So repeat job. And now if I go in to my documents and find that file that I just processed, I can look and I can open it up with packs. Okay. And if we zoom in a little bit, I can turn off some of my channels, and you can see that we got a pretty full gamut utilization of the profile. We're using every available color in every available instance, which is in some cases great, especially for images. But in some cases we want to have a bit more control with that. So I'm going to jump back over to ColorAnt, or CoPrA. I'm going to go back, and now I'm going to make some adjustments with this color setting. So going in here, I am going to turn off my cyan and turn off my green and violet, right? Excuse me. We're going to leave green on. And you can see that with the auto, it already redefined green as a primary color. So now we have a green, magenta, and yellow profile with black as our black channel still. So we're going to hit apply. And you can see that if we look at our gamut, we get chopped off pretty bad in the back there, but we could have expected that. We got rid of all of our blue channel. I'm going to go to next and save this as GMYK. and hit save there. Now it's processing. If I go back to ZePrA, I can go over to my profile and change it to this new GMYK. As you can see that it's still in the 7-color window because that measurement data is not deleted. It's just not being used in the channel separation settings. So now hit save, and I am going to jump on over to my overview window, and I'm just going to reprocess that file. And processing. All right, and there we go. So if I jump, and now I can see I have my new file here. I'm going to open that with PAX again. Zoom in, and we can already see a pretty substantial difference, which we should because we don't have a cyan. But it's still doing what I would say is a fairly good job. The grays look very good. Everything, looks like a file that's processed without cyan. But if I go and now turn off my channels, as you could probably guess, there's nothing in the cyan, nothing's changing in the orange, nothing's changing in the violet. But if I turn off my green, it obviously is showing this separation. So creating specific profiles for specific circumstances is made a little bit easier. And one more thing to show with this is if we go back to CoPrA, we go back, you are required to have 3 primary channels to kind of build out your gamut, but you're not required to have black. So we're going to turn that one off. We're going to make sure that we do our auto, didn't do anything there, so we can just double check everything looks right. We have green, magenta, and yellow. Okay, you can see that now our profile is getting pretty clipped off in certain areas, but let's see what this does. I'm going to remove the K from that, save it out. And now, if I go back to ZePrA, hopefully it's saved by now. There we go. So now I have this GMY profile. As you can see, it's still saying it's a 7-color profile because we still have that information inside of it. It's just not being used in the channel separation setting. So I'm going to save that. And now go back to my overview, and we are going to repeat that job one more time. All right, and it's done. Jump back over and open that with PAX. And as you can probably expect, the difference between, let's see if we can find that other one. Excuse me, sorry. I was trying to figure out, that's what I was trying to do, grab the correct one. So if we turn our black channel on, that's why. I was looking for one with proper gray balance, but not proper color. So I had the black channel off still. So you can see now, without black, our gray really is not usable in this green, greenish gray, let's call it. And this profile is just doing the best it can with what it's got. But I can turn off every channel but black, there's nothing there. Now, if I turn on these couple, you can see that that's the full width of the gamut there. And, I would say that's still doing a pretty good job maintaining the color despite, not having a blue channel at all. So that is the channel settings function. It's got some pretty cool applications. Now, this is probably not the main application that you would want to use it for, but I think this best demonstrates what it's actually doing.
All right. Finally, we're going to be taking a look at the minimize output channels function in ZePrA 11. First, let's take a look at our file. As you can see, we have 5 spot colors. The first 3 are going to be pretty easy to hit with most CMYK builds, but we want to keep a close eye on these last 2 because that's where some expanded gamut may end up helping us, obviously, with this orange and this green. Looking at our test config, we have a multicolor profile in here, a 7-color. It's orange, green, violet, pretty standard. And I'm going to keep the minimize output channels function off for now and see how it processes this file. Do a drag and drop. It's going to output my new file there. But I'm going to look at the job report and see how it processed those 2 colors. And as we probably could have guessed, this one, it has a little bit of magenta, a little bit of black, and a lot of orange. And the green got processed with about 50% black and a lot of green. As we could have expected, very low delta E's across the board. I think we'd be happy with that. But if we're in a manufacturing setting, there may be benefits to minimizing the channels, the number of clicks, the number of plates that need to be created, etc., etc. So let's see if we can output this to the same quality, but save a couple plates or clicks. So we're going to open this up, turn on the minimize output channels, save that out, go back to my overview, and I'm going to reprocess that job again with drag and drop. Now, the first time that you process with the minimize output channels, it's probably going to take about a minute or 2 to calculate all those profiles. And what it's actually doing is going in here. Let's see if I can find mine. It's going to create a version of not every one of the combinations possible, but every one of the CMYK combinations possible, and save that to your profiles. Now, I already did that, so we don't have to sit here and wait, but it's going to take a little bit of time. It's not going to take a ton of time. So let's look at how the minimize output channels affected that job. So this is the spot colors processing section. And if you look here, we can see that it actually dropped the green. It decided to build this green color with cyan, yellow, and black. Excuse me. And if we scroll down a little further, we can see that it actually scores how well each of the variants did. So we can see that the next one up is actually orange and violet along with CMYK, followed by orange and green. And you can scroll down and see how each one of these performs. But the nice thing about it is it already processed the file, assuming we wanted the most optimum variation. So this new file is built with no green in it. So we're only running a 5-color job. And once it's set up, it kind of just runs. And if you just allow it to, it will convert your files in the most optimum setup. And you don't really have to babysit it all the way through. So let's take a peek at 2 other jobs. The first one, it's got some more green in it. And the goal is obviously to force the ZePrA engine to utilize green as an expanded gamut color. In this case, these are two greens that we're probably going to struggle to hit. So let's just run it through. And the other 5 colors are the same. So those 2 colors were added. But we still have to deal with that orange color. And if we scroll down, we can see that the most optimum profile was an orange-green profile with CMYK. And so now you will see that 562, which was not using green in the other optimized one, it now does take advantage of the green being there, which is good. And we're going to do one more. This one obviously being violet, and process that through. Again, it will take a little bit longer the first time, but only the first time. Once it calculates those profiles, it's going to move as fast as your machine can move. So open that up. And as we probably could have guessed, the optimum variation is CMYK, orange, and violet. And so it dropped green out and is back to a CMYK build for this, and using orange up in this 2020 color, and using violet in 266 and 527. And that, I think, is where we will call it for today. But you can always check out our what's new on our website, as well as using the Help Center